Number 1 says identify all values of x for which it is undefined. Undefined, we know, comes from the denominator, so I am not going to focus on the numerators of my fractions at all. I'm only going to look at the denominators. In order for it to be undefined, my denominator cannot be equal to 0. So we're going to look at each individual parentheses. If I have x plus 2 and I were to set that not equal to 0, I would get that x cannot equal negative 2. It is always just the opposite of what's inside those parentheses. So from this one, I would also get that x cannot equal positive 9, x cannot equal positive 4, and x cannot equal negative 7. Go ahead and try number 2. Example 3, we are multiplying, and we are multiplying, it looks like monomials here. These are all examples of monomials because nothing is being added or subtracted together, as we saw in example 1 and 2. So because we're multiplying, I don't have to flip or anything. I'm going to start with just reducing my fractions. Anything on the top can reduce with anything in the bottom. So 4 and 8 can both divide by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. I like to stop there and then multiply across. So 1 times 2 gives me 2. It looks like we have 2 x's on the top. We have 5 z's and 7 y's. On the bottom, I have 5 times 2, which is 10. I'm going to put these variables in the same order as the numerator. So I have 4 x's, 2 z's, and 2 y's. Again, number-wise, I can reduce 2 and 10. They can both divide by 2. 2 divided by 2 is 1, and 10 divided by 2 is 5. So I'm left with 1 over 5 here. X squared over x to the 4th. These 2 x's are going to cross off or cancel out with 2 x's on the bottom. That will leave me with 2 x's left over in the denominator. You can think about this as subtracting exponents. So 4 minus 2 leaves me with 2 in the denominator. For z's, I have 5 z's on top, 3 on the bottom. So these 2 will cancel with 2 on top, leaving me with 3. And for y's, I have 7 and 2. 7 minus 2 gives me 5 y's on the top. Go ahead and try example 4. Example 5 says, are the following expressions equivalent? Show your work. And it gives me kind of this crazy fraction over here and 3 over y minus 3. I'm going to ignore this here and try to solve this expression on my own, and then I'll compare it to what they say the answer is. So I'm going to leave this 3y, but I should be able to factor y squared plus 4y minus 21. So the a times c, first number times the last number, gives me negative 21, so that's what I'm trying to multiply to. And I'm going to try and add to that middle term of 4. The two numbers that multiply to negative 21 and add to 4 should be 7 and negative 3. There's no lead coefficient, so I don't have to worry about dividing these by anything. So my factors are y plus 7 and y minus 3. In the denominator, I'll leave this y and the y plus 7, nothing to factor there. Y squared minus 9 is a difference of perfect squares, so I can square root both of those, giving me y minus 3 and y plus 3. Now that everything's factored, we're going to try and reduce. So I'm going to cancel out anything that I see that is the same on the top and the bottom. I see y plus 7s and I see y minus 3s. These y's can also cancel out, which leaves me with 3 over y plus 3. So going back to the question here, are the following expressions equivalent? Yes, they are equivalent, because after factoring, all other factors cancel, and it leaves me with 3 over y plus 3. Oh, I'm sorry. No, it looks like they're not actually the same because this was a -3 and this was a +3. So no, they are not equivalent. Go ahead and try example 6. Alright, example 7 has me multiplying. These are no longer monomials because I'm now adding and subtracting, so I'm going to have to do some factoring here. My k minus 3 should stay the same. K plus 1 will also remain the same. 1 minus k squared. This is an example of difference of perfect squares. I can square root both of them. It's a little tricky because it's kind of out of order of what we're used to seeing. We usually see the variable first. But when I go to factor, I'm going to leave it in just the order that I see. So I'm going to put the square root of 1, which is 1, first. Square root of k is just k. And I'll fill in 1 with a plus and 1 with a minus. The denominator here, we're going to factor traditionally, so factoring with these blanks. My first times my last, or a times c, is 1 times 3, which is 3. And I'm adding to this middle, which is a -4. The two numbers that multiply to 3 and add to -4 are -3 and -1. So my factors should be k minus 3 and k minus 1. From here, I'm going to cancel out anything that is the exact same. So I have k minus 3's. 1 plus k is the same as k plus 1, so I can cancel those. And from here, I'm left with 1 minus k and k minus 1. Now, at first glance, I do think that these look almost the same, but they're actually exact opposites. This is a negative k and a positive k, a positive 1 and a negative 1. So what I'm going to do is factor out a negative 1 from the numerator. So if I take a positive 1 and I divide by -1, that gives me a -1. And a negative k divided by a -1 gives me a positive k. Now these are still a little bit out of order, but I have a positive k and a -1, so these guys cancel, leaving me with -1 as my final answer. Go ahead and try example 8. Alright, example 9, we are now dividing. We've learned that when I am dividing, I'm going to change it into multiplication and flip my second fraction. So I'm going to rewrite this first fraction. It is not changing, but I'm going to change to multiplication and flip this second fraction. So d plus 3 will now be in the denominator. 3d squared plus 7d plus 2 is now in the numerator. Just like we saw in example 7, we will do a bunch of factoring now and hope to cancel things out that are in the same on the top and bottom. 2d plus 6, this is only two terms, and I'm noticing that 2 and 6 can both be divided by 2, so I'm going to factor using GCF here. If I take out that 2, 2 divided by 2 is 1, so I have just d, and 6 divided by 2 gives me 3. In the denominator, I'm factoring just traditionally, so I'm going to use my blanks up here. I should be trying to multiply to -2 and add to +1. The two numbers that multiply to -2 and add to 1 are 2 and -1. No lead coefficient, so no dividing is necessary. So I have d plus 2 and d minus 1. Moving on to my next fraction, I'm going to factor in this numerator here. A times c gives me 6, so I'm trying to multiply to 6. And I'm adding to 7. Those two numbers should be 6 and 1. Now this is a little trickier because of that lead coefficient of 3. I'm going to have to divide both of these numbers by 3. 6 divided by 3 is 2, so one of my factors is d plus 2. 1 does not divide by 3, so we'll put the denominator with the variable, so 3d, and the plus 1 will be after it. This denominator of d plus 3 cannot factor, so I will leave that the same. From here, I'm going to cancel out anything that's the same in the numerators and the denominators. So I see d plus 2 and d plus 3. I am left with a 2 on top and 3d plus 1. In the denominator, I'm left with d minus 1. Go ahead and pause your video and try example 10.